So welcome guys, welcome to my channel. So today in this lecture I will discuss three problems on GATE 2017 of 2 marks. Okay, so first problem is here that the mobility of a univalent ion in aqueous solution is 6 is this one with unit at 300K. So its diffusion coefficient at 300K is x into this one. So the value of x is, so here actually they wanted to know about the diffusion coefficient actually in the form of x. So they wanted to know about the x, so and it is given that of values of ionic mobility, okay, of univalent ion. So we have to relate first the relation between diffusion coefficient and ionic mobility. So this is a problem of conductance, right? So as we know, there is a relation between that mobility and diffusion coefficient is that is given as d is equals to mu kVt by q. So d is the diffusion coefficient, okay, diffusion coefficient, and mu is the ionic mobility. So this is actually expressed in terms of mu, okay. Kb is the Boltzmann constant, okay, and T is the temperature, Q is the charges. So univalent, that means that will be 1. So that this is the 1, so it will be mu kBt, okay. And now it is given that D equals to x into 10 to the power minus 9 meter second inverse, and the value of Kb, okay, value of Kb in terms of volt will be, that will be 8.6 into 10 to the power minus 5, okay, electron volt Kelvin inverse, okay. So this is the case actually now, and mu equals to 6 into 10 to the power minus 8 meter square second inverse volt inverse. So t equals to this one, so just we will put the values as, so d equals to mu kBt, okay. So d equals to x into 10 to the power minus 9 will not, mu equals to what, mu is equals to 6 into 10 to the power minus 8, and kb equals to 8.6 into 10 to the power minus 5, okay, and t equals to 300. So just calculate, simple calculation, okay, and you will get the value of x. So the value of x, that will be 1.548, okay. So this is this problem, like this is simple problem. So in this way we can solve this problem, okay. So this is the answer, okay. So let's move to the next problem. So next problem is from chemical kinetics. So actually I have didn't give the proper sequence as that was in the GATE paper, because in the earlier lectures I have discussed also 3 problems on this GATE 17, right? So all these questions I have discussed, I am discussing now, and I was discussing, I discussed that class, those classes about GATE 2017 of 2 marks, okay. So here it is, the problem is that for the following consecutive first order reactions x to y to z, so k1 is given for this step and k2 gives to rate constant of this step, these are given, okay. And they said that the time in seconds required for y to reach its maximum concentration, okay, is, so maximum concentration for y, okay, right, and assuming only x is the present at time t is equals to 0, okay. So here is the graph, actually the graph is given as this one, that is for consecutive, okay, this is the concentration, time, and this is for a b c. So obviously in initially there is what, only a, so and at time t it is 0, so 0 time only a is there, that's why this is the concentration of a. As the time passes, this is the first order follow, so a decreases according to the first order reaction exponentially, okay, and as the time increases the concentration of y, that means, sorry, here I designate as a b c. A means x, actually a means x, and b means y, and c means z. So as the time increases, the concentration of y increases, and after certain time it decreases, and the concentration of c or z increases, okay, certainly, okay, after certain time it also increases. Now they wanted to know, actually here are 2 cases are there, okay, I am not going to that one actually. So here actually, so they wanted to ask the maximum concentration of y or b. So this will be the concentration, and the equation that is actually that can be derived, but we will not derive here, we'll just write direct the equation. So the equation is T max is equals to 1 by K2 minus K1 ln K1 by K2. Okay, so this is the equation, and here you have to remember that this K1, this will, so this negative will come actually above here. Okay, so just putting the value we will get the answer. So K2 equals to 0.1. okay, and K1 is equals to 2, and here it is, so it is log, I'm converting it log, and it is log K1 by K2. So K1 equals to 0.1 by 2. So just here, so if it go above, there will be a negative sign. The negative sign will be removed and is also changed. So that means it will be T max is equals to what, 2.303 by 1.9 into log of 2 by 0.1. So 2 by 0.1 means 20. Okay, so this one, so as this negative sign will come, and here also if I exchange this one, it will go above, it will go below, so this negative sign will be removed. So this will be the final equation actually. Okay, so and the answer will be here actually 1.57. so the answer will be T max will be 1.5 second. Okay, so this is the answer. Okay, so next problem, so let's move to the next problem. So in this way you can solve this problem actually. Okay, so for your GATE exam purpose, so these problems are very important, like consecutive, parallel, or opposing reactions. Okay, this is very important. So let's move towards the next problem. So next problem is here. So under physiological conditions, the conversion of CO2 to bicarbonate ion by carbonic anhydrase enzyme. So molecular weight, this one has a turnover number of this one. So the minimum amount of enzyme required to convert 0.44 gram of CO2 to bicarbonate ions in 100 seconds is. Okay, so in this case actually they want to know about the turnover number. Okay, so I have done it as it is a little bit lengthier. So as we know that turnover number, so the turnover number equals to moles of product. So for any kind of enzyme reaction, so the moles of product by moles of enzyme into time interval. So this is the turnover number for any reaction that is characterized by enzyme. Okay, so turnover number means again I'm saying moles of product by moles of enzyme into time interval. Okay, so in these cases actually moles of time interval is given, turnover number is given, and moles of enzyme is not given, but weight of the enzyme is given, molecular weight. So molecular weight means 30,000. Okay, and they wanted to know about the minimum amount of enzyme, that means less it is the W. Okay, so this W means moles of enzyme is W by 30,000. Okay, and moles of product we have to just calculate. So we'll just put the values in terms of in place of moles of enzyme, we'll put W by 30,000, time interval is given, this is given, and we'll calculate this one, and in this place we will put the W by 30,000, and just putting those values we will just calculate that W, the minimum amount of the enzyme. Okay, in microgram. Okay, so let's, here turnover number is this one, molecular weight of enzyme carbonic anhydrase enzyme. Okay, so this is actually 30,000 gram per mole. Okay, and amount of enzyme, let's it is the W, we have to calculate, and now we have to calculate this moles of product. How? So here it is this is given that carbon dioxide, this enzyme means carbonic anhydrase. So we know, we have read in biology that carbonic anhydrase enzyme converts CO2 into bicarbonate. Okay, bicarbonate ion. Okay, and in this case actually we have to calculate first the how many moles of product means HCO3 are formed. So as we know that 44 gram means 1 mole to 1 mole of HCO3 minus 61 grams. So just calculating this one from 1 mole of CO2 we can get this one. So 0.44 mole will get this amount. So this amount means how many moles, so that will divided by the molecular weight. So this is this one. So moles of product will be 0.01. Okay, and from 1 means this equation 1. So we know this equation I have written here, and again I'll just put the value. So turnover number is given as this one, and moles of product I have calculated this one, and moles of enzyme equals to this one, so W by 30,000. Okay, and turnover time interval equals to 100. So just calculate this. Okay, this is simple calculation, you will get the answer. So answer will be the 7.5 microgram. Okay, this is the case actually. So in this way, suppose this same kind of numerical you can solve in this way. So this is the case actually. Okay, so thank you for watching this video.